Welcome to this session. This session basically will deal with object recognition, and I will be using YOLO model for that. So before getting our hands on the notebook, first let's understand what is the meaning of object recognition. So basically, in computer vision tasks, object recognition it refers to the task of identifying and classifying objects within digital images or video frames, and it involves the use of computer vision techniques and machine learning algorithms to automatically detect and thereafter recognize objects of interest in the visual data. Goal is to assign meaningful labels or categories to objects in an image. I will give you an example. For example, we have got 1,000 images, and we have to detect people who are wearing helmets. So that is the kind of task which is used. Or for example, uh, in the traffic, you want to identify cars. For example, you have got thousands of images for 10 days of data, and you want to count the number of cars, or you want to know the type of cars also. So that task comes under this category. So it involves basically identifying common objects such as cars, people, animals, or a specific object like I mentioned, like helmet. Or we can also um, identify specific object instances such as particular breed of dog or a specific model of car. So after covering this basic and understanding the meaning of object recognition, I will cover the typical steps. So there are basically four steps which are used in object recognition. First is the pre-processing, and step basically involves preparing the image data for analysis by performing operations such as resizing, normalizing, or enhancing the image so that it can be consumed by that model, because that model expects uh, the images or the data in a particular format or a particular size. Thereafter, we extract the features from that image. And these features, they can be low level visual descriptors like edges, corners, or textures, or even higher level features which are learned from deep neural networks, especially the CNNs, which are used in computer vision. After this, then we either do uh, classification or we do detection. So these extracted features which are there, which we have taken, they are used to classify the objects or detect their presence in the image. So classification involves assigning a specific label or category to an entire image, while detection involves localizing and classifying objects within an image. And the last step is finally post processing. So once we have done the classification or detection, then we apply post processing techniques like we refine the results such as filtering out false positives, grouping detections, or estimating object poses and attributes. So basically, there are three computer vision tasks. First is image classification, that we predict the type or class of an object in an image. The second is object localization, where we locate the presence of objects in an image and indicate their location with a bounding box. And object detection, basically it consists of both. It it localizes also, and it classifies also. So it basically locates the presence of objects with a bounding box, and then it predicts the class of that located object in an image. So having understood the meaning of object recognition, now we move to one of the most frequently used model now these days, YOLO, which means you only look once. So if we see the history of computer or this object recognition, then we have models like faster CNN, but there they have got two steps. One, they do the localization, and then second, they do classification. Whereas in YOLO model, it does detection in real time, and both the steps, that is the localization and classification, it happens on the fly and it happens in one go. So it involves a single neural network which has been trained end to end, and it takes a photograph as input, and then it predicts bounding boxes and class labels for each bounding box directly. So this model basically works by first splitting the input image into a grid of cells. So either 7 into 7 or 13 into 13, depending on the YOLO model or the version of model which you are using. Now, each cell is responsible for predicting a bounding box if the center of a bounding box falls within the cell. Then each grid cell predicts a bounding box involving five things. One is XY coordinate and width and height, and last is the confidence. A class prediction is also based on each cell. For example, an image may be divided into 7 into 7 grid, and each cell in the grid may predict two bounding boxes, resulting in 94 proposed bounding box predictions. And thereafter, the class probabilities map and the bounding boxes with confidence are then combined into a final set of bounding boxes and class labels. So just to give you an example, this is an image. So first, uh, 7 into 7 grid has been made, and in every cell now there are two bounding boxes which are made, and bounding boxes have got X, Y, W and H and confidence. And then we have got a class probability map. So these are the probabilities for an object, or different colors signifying different objects. And during inference, what happens now, once this model has been trained on the various data sets, then during inference now, with those trained weights, you give an image, then it will give these bounding boxes. And using something called NMS, now you will select the bounding boxes which have got the highest probability, and you will keep on merging the adjacent boxes. And finally you get, for example, in this image, we have got three bounding boxes with three objects. So one bounding box is for car, second is for bicycle, and third is for dog. So I'll explain YOLO again step by step. So first we divide the image into a grid of cells, and each cell is responsible for predicting a set of bounding boxes and class probabilities. Thereafter, for each cell, the YOLO algorithm predicts a set of bounding boxes and class probabilities during inference. Now, bounding boxes are represented as four coordinates: the top left corner, the bottom right corner, which is the X and Y, the width and the height of the box, and the class probabilities represent the probability that the object in the box belongs to a particular class. Thereafter, we apply non-max suppression, NMS in short. The bounding boxes predicted by the YOLO algorithm may overlap. For example, there may be four bounding boxes showing the presence of a dog. Now, to remove overlapping boxes, the YOLO algorithm applies this non-max suppression algorithm. This algorithm will keep the box with the highest confidence score, and it will remove all other boxes that have a high overlap with the selected box. Thereafter, it draws the bounding boxes and adds class label on the image. So that is the final step. The bounding boxes are drawn in a different color for each class, and the class labels are displayed next to the bounding boxes. So YOLO in summary is basically YOLO divides the image into a grid of cells. It predicts the bounding boxes and class probabilities for each cell, applies non-max suppression to get the bounding box with the highest probability and to remove other adjacent boxes. And fourth is draw the bounding boxes and class labels on the image. Okay, so now after covering the object recognition and YOLO model briefly, let's now get our hands on the notebook. So for this session, I have chosen Kaggle because we need a data set to train which is having this information. So we need the information of this bounding box, for example, X, Y, W, H, and confidence. So for training, we need an image, and then we need the information of these bounding boxes in the labels. So Kaggle has got, for this particular session, I'm using multi-class detection, and we have got a data set on Kaggle. But don't worry, we will add the Colab version also of this. And in Colab, just we have to log in into the Kaggle, and thereafter we can use the data set. Okay, so let's start. So first of all, to use the YOLO model is we can use after installing Ultralytics. So let's install it first. And I have selected the accelerator, GPU P100. Same thing you can do on Colab also. So our download has started and it will install. While it is installing, after that we will import the necessary standard libraries like NumPy, Pandas, OS, Random. From Ultralytics, we'll import YOLO, basic model, and we will use Matplotlib, PyPlot for plotting. We will use CV2 to read the image, and we will also use image from PIL. I'm using random seed 42 for standardizing. Okay, so it is downloading. And after importing these libraries, there is we can use the YOLO check. So once you do the YOLO check, it gives the entire information of that YOLO which you have imported. So for example, it has given from Ultralytics 8.3.205. This is the information of the GPU which we'll be using. There is a 4 CPUs. So it is the basically setting up of the YOLO. So entire information is there. Okay, let's see whether this has been installed or not. Okay, let's download our libraries first, and then we can do our YOLO check. Okay, so it has installed. We have uh, imported necessary libraries. Now we can do YOLO check. And for this session, like I mentioned earlier, I'm using this object detection wildlife dataset YOLO format, which has got a multi-class detection. So there are 4 classes in this dataset. So let's see its okay. There is some problem in Kaggle. Maybe load is high. So again, we'll restart this. Or I can show you the Colab version. Okay, we are using that. So for Colab version, what we have to do, first we have to log in with our Kaggle. So first we install, for example, Ultralytics. We install it, and here is the one to use the dataset from Kaggle. We have to import Kaggle Hub, and then we have to log in Kaggle Hub. So to log in, what you have to do, it will ask you your Kaggle username and it will ask you Kaggle token. So Kaggle token you can easily get. You can go to, so for example, already I had used this. So my token is saved in the passwords. So I'm logging in. So I have done login and now I can use the dataset from Kaggle. Okay, so this already I have installed Ultralytics in this. So now I import the necessary libraries. It is importing. Okay, so it has, then I can do the YOLO check. So this will do the setup of YOLO and then it will give the entire information. So setup is complete. So I'm using Kaggle, that's why it is showing 2 CPUs. And I have selected in the runtime. So we can use the sessions. So here is the change runtime. So I'm using T4 GPU. So this is from Tesla. So this information has come, everything YOLO has come. Now I will give this data set because I'm using the data set from Kaggle. So this is the name of the data set. This is Ankan Ghosh 651 underscore object. So this I'm giving the data set directory. And now let's see its top level structure. Okay, dataset directory, it is not showing, it is not there. So let's check where we have to give. I think if I'm not wrong, we have to give in starting. Yes. So in the starting, after login in the Kaggle, we have to give the path. So this is the Kaggle dataset download. It will download this dataset. Okay. So it is downloading. It will take a while. Okay. It is now 100% downloaded. Data source complete. Okay. So this was missing. So here we come and now we give the dataset directory, we give the same part to it. So now in this uh, dataset directive which we have downloaded, the top level structure, it has got final data. This is the folder. So let's see what is inside this final data. So final data has got train, test, valid. So this train, test, valid will have images and the label data, and this data underscore WL YML is a YML file which is required for the YOLO. So I'll cover that later. How do we build a YML file? And when you train a YOLO model, you need this YML file. So I'll cover what is included in that YML file. So first, let's see what is there inside the train. So in train, we have got images and then we have got labels. So we'll see one by one how they look like. So first, what do? We make the train directory, and so in the train directory, we are joining the dataset directory, and then we are selecting final underscore data train images. So this is the train directory, and for this we are taking the label directory train, and for that we are taking the labels from the same train. Validation directory, for the same we are getting the images and the labels. So, and we will be using all the image files in the train directory. So we, in this data set, we have got images either in the JPG format or in the JPG format. So okay, so we have built these directories, and now we can count the number of images in each directory for in the train directory and validation directory, and we can see how many images are there. So there are total 1353 images are there. Around 89% are there in the train directory and around 11% in the validation directory. Okay, now let's see how one image looks like. So we'll randomly select one image from the image files using random.choice. We give image path, we join the train directory with this random image. We are using CV2 to read this image path, and when CV2 reads an image, it reads in BGR format, whereas for display by matplotlib we have to convert it to RGB. So here we are converting, and thereafter we are displaying. So this is random. So this is, for example, there is an image with 2 or 3 elephants. So let's see another image again. Okay, so these are buffaloes. So there are 4 buffaloes here. So we know that there are, okay, now we have got zebras, and zebras. So now to know how to, how many classes are there, we will get the information of all the classes, and this will get the classes from the labels. So labels file, basically it ends with txt. From there we are getting all the class information. Okay, so there are distinct classes which are 0, 1, 2, 3. We don't know what is for elephant, what is for buffalo. So let's see. So what we'll do, we know that there are 1353 images. We'll see the images after regular intervals to see these classes. So I've selected these images: 20th image, 380th, 820th, and 1320th, to see what all kind of images are there or what kind of classes are there. Okay, so we have got buffalo. This is the 20th image. So, and this is elephant, and then we have got rhinos, and we have got zebra. So our class label 0 basically denotes buffalo, 1 for elephant, 2 for rhinos, and 3 for zebra. So these are the classes, and now let's see how these labels they look like. So from labels, I've selected 10401.txt, which is basically corresponding to image 0401. That is its label. And let's see how does it look like. How are the labels they look like. Okay, so label path is just, we will do something here. There's an error. So what we'll do, we'll add our label path train directory, and we'll get the labels, or we have to run again. Okay, so I'll just show you in Kaggle how does this look like. So labels, like I mentioned earlier, the labels have got X, Y, WH, and the confidence. So I have run this on Kaggle. So there is an error coming there. So the information will come like this. So X min is there, Y min is there, X max is there, Y max is there, and the class information is there. So this is the label, and we need this kind of data for training. And you can see here it is giving uh, 2 rows. So it means in this image there are two same class animal is there in a single image. Okay, I will just check this. What is the error? Why it is coming? Let's run this. I think Kaggle input detection wildlife. So 401. I will just pause this. Okay, so there was an error in the path. I've rectified it. So label file path, basically it is dataset directory, and then I'm joining final data train labels 0401 txt. And like we saw on the Kaggle, it has got C 2 rows, and it is giving X min, Y min, X max, Y max, and there is a class. So this image, basically it has got two animals of same class in this, and this is the label data. Okay, now what we can do, we can check this image. So we can, the label was for 0401, so we find the same corresponding image, and then we read that image, and then by CV2, and let's see. And before displaying, see this X min or Y center, width and height, they are in the relative figures. So before displaying, what we have to do, we have to convert that to standard. So see this, we are reading the labels. So the yellow labels, we are reading the lines from that file, and it will give class ID, X center, Y center, width and height. So this, where we had given, so this was width, this was X, this was width, width, and this is height. So this is the information which is there in the labels. So okay, so this is the X, Y, width and height. So what we have to do, we have to now, the image width which is there, we have to get the absolute pixel values. So we'll have X center is equal to X center into image width. This is the X center, Y center again, Y center into image width. Width will become width into image width, and height into image height. And thereafter we get the bounding box corners. So we get x1, y1, x2, y2 from the information from X center, Y center. From X center minus width by 2, we'll get x1, Y center minus height by 2, we get y1. Similarly for x2, y2. And thereafter we will make the rectangle. So let's see what is the image. Okay, so this is the image 0401, and like labels had suggested, it has got two classes, that is elephant, and there are two in this image. So this is the bounding box for first image, this is the second. So I would like to mention here, this is the training data set where we have got an image and we have got the corresponding labels, and labels have got information X, Y, width, height, and the class name. So this is the class 1. So it means class 1 corresponds to elephant. Okay. Now for training a YOLO model, we have to build a YML file. So YML file basically consists of information about train dataset, well dataset info, number of classes, and the class names. So here we are writing all this information. So we are giving train information, that is a train directory, label directory train, this is for the training. Similarly for the well directory and label directory which we have created. As we have seen, there are 4 classes. So we have given NC, this is 4, and we are giving names. So instead of 0, 1, 2, 3, 4, we have seen 0 corresponds to buffalo, 1 corresponds to elephant, 2 corresponds to rhino, and 3 corresponds to zebra. So I'm giving these class names, and the model now will get trained on this as per this YML file. So let's first create this YML file. Okay, so as we create this, here we can see the files. So this wildlife dataset YML file has been created. And now from YOLO, I'll be using a model YOLO V8M. So this is a basically for this session. I want to have a model which can be trained, which has got a higher speed for training. So that's why I've selected this YOLO 8M, and I will use 8 epochs, and the YOLO expect the image size 640. So here we have to give image size. So this is the main step for training for this YOLO. So let's see what all information will come. So the YOLO has come model, and it will give the information about the model. So there are 169 layers in this model. There are around 26 million parameters and same number of gradients, and 79.1 G flops are there. Now it will start now training. So first epoch has started. So it has got in the YOLO, does it get trained? It gets trained on a regression task. Though it is doing classification finally, but it will do regression on box loss, class loss, and the DFL loss. And then it propagates these losses. So what happens during training, it will instantiate this model which we have downloaded with the pre-trained weights. And now these weights will get updated based on this loss uh, propagating back. So in every epoch, the weights will get updated based on this data set. Okay, the second epoch has started, and it is requiring around 6.5 GB of GPU. So we are using Tesla GPU here in this collab. And while it gets trained, so what will happen? All these weights which are there, they will get stored in your contents run. So here we can see in the files here. So runs has come. In the runs, there will be a folder train or detect, and in the detect there will be a train folder, and in the train you will have these weights. So these are the weights which are there, and in the weights you will have two types. One is the best weight, and the second is the last weight. So this is getting stored here. So our third epoch has started. So while it is getting trained, it will take some time. So here we can see our best weights and the last weights. Now what we can do, now we will use the best weights. So for that we will give model is equal to YOLO, and we now load these best weights from this path where they have got stored. And then we run this validation on the validation set. So what we have to do, we know we have given the information of a validation folder. We just will obtain matrix using matrix is equal to model dot well. So what it will do, it will make your confusion matrix. It will give you the this will information will comes. It will give the R value, it will give the box value, it is giving the mean, average, precision. So all this will come, and we can download these images or the confusion matrix from where it will get downloaded. So these all plots are basically they are automatically saved in a validation folder, and from that validation folder we can get the all these plots. So our fifth epoch has started. Let's wait for it for some time. So now while that this is getting trained, again I will revise. So we started with the object recognition. Object recognition basically has got two parts. One is a localizing of the image, that finding that object in that image. Second is to classify that image. So YOLO is a model which is frequently used. It does both the tasks on a fly and in a single step. And how YOLO works, YOLO basically is trained on images, and to train a YOLO model, you need an image with the image data and with the label data. And in the label data, you need a specific format that you need X, Y, width, and height, and the class confidence. Now you will train this YOLO model on your data set. So once you get this, so the model weights will get updated. Now when you give an image to this model, what it will do with these weights now, it will build those bounding boxes and it will give you the classification. And so bounding boxes, for example, there are 7 into 7 grid cells. Every cell has got 2 bounding boxes. So you will have 49 into 2 bonding boxes if you leave the corners. Now it will use NMS. So basically to merge these bounding boxes, it will keep the bounding box with the highest class probability, and it uses something called NMS algorithm for doing so. And finally, it will give you the binding boxes for the images and it will classify. So that's a basic working of YOLO model. And YOLO model during training, it uses regression. So it has got 3 types of losses. It has got the box loss, it has got a classification loss, and then it back propagates this loss to update the weights. Okay, so now you can see all these losses are coming: box loss, class loss, and DFL loss. I'll encourage everyone to go through this YOLO paper. There is a lot of material which is available online. You can go through that to understand that. Speed wise, YOLO is the best. Accuracy might not be as good as faster CNN, but when you want to use in the real time, for example, detection of vehicles on the roads, then the YOLO model is the one which is frequently used. Okay, let's wait 2 more epochs and then we'll see. So we can see the losses are decreasing: 1.399, then 1.318, then 1.249. So all the losses we can see the model is getting trained. Okay, 9th epoch we have reached. To have a better accuracy, what you can do, so working is like that. If you get a project, so you have to get a YOLO model from Ultralytics, and thereafter you have to train that model on your data set which has been given to you, and then that model which you have got from Ultralytics, for example model YOLO 8, then its weights will get updated as per your data set. And now these pre-trained weights, you will have to load your model with those weights, and then you use model.well to get all the matrices like confusion matrix, precision, recall, F1 score that you will get here, that you can download, and then you can you can check on a new image what its performance. Okay, so 10th epoch has started. It will take a minute. So see, the losses have decreased. So this was for 10 epochs. If you use more epochs, your accuracy will increase further. Okay, so it has now it will give the summary. See, so it has given the time 10 epochs have been completed. It has shown, okay, and it is giving you all the information also, recall. Okay, this is giving you that where it has been saved, content runs, detect train. It has given the information of your speed also. Okay, now let's see where it has got trained. So it has got saved the weights. There are 2 types of weights which have been saved. One is the best weight and second is the last weight. So now with the best weight, we do the validation again to get those matrices. So it will come here, all your matrices will be built and which we can download and we can see. Okay, so these matrices, they have been saved. So this is the path content runs detect well. So we can see detect, it will have now 2 parts. So it has got well. So we can see inside well what we have got. We have got uh, F1 curve for the box. Then we have got PR curve. So all this information is available. Confusion matrix is there. Okay, so we can see what all is there inside. So we can use this. So all this information is there. Now, if we want to see box precision recall curve, so just We read that image with the help of CV2 and see. So for all the 4 classes, it has given the precision recall. So for buffalo 0.91, elephant 0.955, rhino 0.987, zebra is around 0.923. For all classes, it is 0.944, and mean average precision is around at the rate of 0.5. Now what we'll do? Okay, now I want to see, for example, F1 score curve also, and I want to see confusion matrix also. So we will read from the same path. So already we have seen the box PR. This is the same, and this is the F1 confidence curve. So it is given, and then it has given the confusion matrix also. Now what we will do? We will use the best weights, and let's check. For example, we'll read one file from our valid folder, and let's see what it will predict, what is the original. So again, here there is a problem in this. This will not be able to read from because there is a Kaggle input. I'll give the OS path. So image path is equal to, we'll use from top. So we'll check what was the name of our well directory. Well directory was here. Okay, so this is the well directory. And from well directory, we'll get an image to see. So this will become os dot path dot join well dir and we'll give. So this is valid images and just 0365 dot jpg. It's command. So let's see, and CV2 will be reading image path. Okay. Okay. So this is a 0365 JPG. See. So now we are running the prediction on this. So this is a, okay, it is read from somewhere else. So source is missing. Source is local Python or something. Image Python district packages. So let's, okay, so there is a problem in the path. So I have given the correct path. So we have loaded the best rates from this model we are using. Validation directory we have made, image path we are giving to one image 0365.jpg, and we read that image, and then this model will predict on this image, and let's see what will be the, and then we draw the bounding boxes. So we'll uh, plot with the line width of 4, font size is 12, and then we convert the BGR to RGB for matplotlib, and let's see. Okay, so see, this is the image and it has localized correctly with the bounding box. It has given the correct classification and it has given the confidence also, or the probability, that with 0.93 it is buffalo. So it is giving correct. Now let's see on 10 random images from the well directory, and let's see how well does our model predict that. Okay, so see the speed, what I was saying. So it is in 27.2 microseconds, and we get the display also, and we can check. Okay, so let's see. So here it is correctly identified. See, elephant 0.74, but it is showing, yes, it is correctly identified. Here it is a buffalo 0.85. It is a elephant, two elephants with 0.65, 0.73, two rhinos correctly identified, buffalo, rhino again for 0.88, rhino 0.88, elephant. So it is correctly identifying. So see here, here it has not been able to identify or box this elephant. So it has identified one elephant and one rhino. Here it is correctly identified all buffaloes, all the four buffaloes. In fact, there is a buffalo at the back also. So we can see that with even 10 epochs of training, our model is performing fine. If we do more epochs training, we'll get more accuracy also. So that we have checked on the random images that our model is performing fine. And what I will do now, we will check, for example, that how was the performance of the base model. So base model of only YOLO. So instead of loading, so for that what I did, I'll just show you. So here I'm using the same for the Kaggle, but same data set. I'm giving this validation directory, and here I will not use, already have defined well directory. So I'm using only the base model without train weights. So let's see how it will perform. Speed is okay, but let's see how it will perform for the classification and for making the bounding boxes. Okay. Okay. So see, you can see for zebra, it is correctly making the bounding boxes, finding two zebras, giving correct. Here it is found zebra, but you see here buffalo, it is identifying it as cow. It means that our base model has not been trained on buffalo, and it is identifying this buffalo as cow. Similarly, here it is identifying this cow, buffalo as cow. Same here. Here it is identifying this as an elephant. So rhino, it has been identified as horse. Here it has been identified as cow and horse. So we can see this is the significance of training a base model on your training data set. So whatever task you want to do, you have to have the data set for that, and you have to have labels in the YOLO format. Then you can train, and then you can achieve. So I had made one image with the elephant, giraffe, and zebra. So I will upload it on this, and then only we can use. So let's see, it was in the downloads. I'll just see. Okay, so this is an image I created with the help of AI, and it has got three animals. So let's see how our model, this trained model now, will work on this. Okay, so it is uploading. It will take some time. Let's see. So see, this is the image which I had created with the help of AI, and it has got three animals, and all the two animals, which are zebra and elephant, they have been correctly identified. The bounding box has been correctly made. However, this model was not trained for giraffe. So see here, it has made the box, but it has incorrectly classified it as zebra. But we can see the confidence or the probability is less. So we can make out, if we want to analyze that, we can say that no, it is not zebra, but it is a different animal. But our data set did not have this animal. So we have seen the efficacy of this. So with this I have finished. So main takeaways, key takeaways from this session are basically to understand what is the meaning of object recognition. Then we discuss YOLO model, its basic methodology, how it is trained and how it performs during inference. Then we used a data set for 4 classes from Kaggle. We trained our YOLO model, YOLO 8 V 8M, sorry. And then we checked on a random image. We also checked on the data validation. We got the confusion matrix, all other curves. We could download that. And then we also tested our model on a AI generated image. So with this, I have finished. Happy learning. Wish you all the very best. Take care. Bye bye.